2.8, graphing absolute value functions. Okay, so for this and all other functions that we're going to be graphing this year, we're going to use what's called the parent function. Okay, now the parent function is the graph of the most basic function for that given function. Okay, so for example, we're doing absolute value functions. So we're going to graph f of x is equal to the absolute value of x. There's no shift or anything given this equation. Okay, so you know if you do an xy chart, and let's just say -2, -1, 0, 1, and 2. That's saying plugging that x value in, and what do we get for y? Because remember, f of x is just representing y. So when you plug -2 into here, absolute value of -2 is 2. 1, 0, 1, 2. It's always, remember, absolute value is the distance away from 0. So if you're -2, you're just 2 away from 0. So let's plot those. I'm not going to do a scale or anything. They're just going to look like this. But what you're going to notice is that it's going to look like a V. All of our absolute value functions will look like a V. Okay, now we're also going to have some shifts, some reflections, some shifting left and right. Okay, it's going to look a little bit different once we start adding things to this function. So the general function, f of x, is equal to a times the absolute value of x minus h plus k. Now this a, h, and k, they're representing a part of this function, and we're going to be seeing a, h, and k throughout the whole year. Okay, they're going to have some type of effect on the graph. Okay, a is what is going to cause these graphs to either go narrower or wider. Okay, and if you have a negative a, that's going to cause a flip or a reflection. Okay, h, that's going to be our shift left and right. And then k is our shift up and down. Okay, that's how a, h, and k are going to affect the parent function once we add those into the equations. Okay, so the first example, when we're doing these, the biggest thing is to find that vertex, okay, that point where it connects. Okay, so if you remember, h and k is where it causes it to shift left and right, up and down. So that is where we're going to find our vertex. Vertex is h and k. Now remember, a times x minus h plus k. So for that h value, you actually have to think of the opposite. Okay, it's saying x minus 3. So our h value is 3. So always think of opposite of what you see for h, and then what you're actually seeing for that k value. So our vertex in this case is 3, 1. Now, what determines it if it opens up or down is the positive or negative a value. In this case, we just got a positive 1. We don't need to write that in there. So in this case, it's going to go up since it's positive. And since it's 1, it's just going to stay the same as the parent function. We're not causing it to go narrower or wider. Okay. Now, the way we're going to do this is just a little chart. Okay. On this chart, you're always going to have these x values. And the values we're going to use, -2, -1, 0, 1, and 2. Those are the values we're going to use always with these absolute values. Second box, that's going to be our function. Parent function, in this case, is absolute value of x. Okay, so the absolute value of -2, because that's the x value in this case, and then all the way down. Okay, it's always just that positive value. Now, in that third column, this is where we're going to take care of that a value. in this case, it is just 1. So 1 times the absolute value of x. So we're taking 1 times this whole column here. Okay? And since it's 1, it's literally just the exact same thing. Now, once we get to this point, we're actually going to completely ignore that middle column. Okay? And what this is going to tell us is the x and y where we're going from our vertex. Okay? So -2, 2. That's telling me left 2, up 2. Okay? X is always our causes with us to go left and right. The y is always up and down, just like on a coordinate plane. So we're going to go left 2, up 2, from the vertex. Okay? So with this table, we're just taking care of the a value. We took care of h and k with our shift left and right, up and down. So -1, 1, we're going left 1, up 1, right 1, up 1, right 2, up 2. And there we have our graph. Now, we need to talk about domain. When you're looking at a graph, domain is basically how far left and right is this graph going to go, okay? Or what x values can I plug into the function and get something back, okay? And if we look, that's going to go left and right forever. It's never going to stop. So in that case, the way we write this, domain is always dealing with our x values, and since we can include everything, we're going to use this little thing, okay? It's like a backwards E, okay? It's the element, x is the element of all the real numbers, okay? That's how we represent all real numbers, because we can plug everything into it and get something back. Now the range is dealing with our y values, okay? What type of y values can I get back when I plug an x value in? Nice thing about the graph, it's a good visual, okay? As you notice, it is everything above that 1, okay? Because we can get 1 for y. This is 3, 1, and we're looking at that 1 here, and I can get everything above that. So all the y values that I'm going to get is going to be greater than or equal to that 1. Okay, so basically how far up and down does that graph go? If that graph is everywhere above 1. All right, now let's look at actually throwing in an a value there. Okay, again, find that vertex. And again, vertex is always that h and k. And for the h, you have to think opposite. So 2. K, you think of what you actually see. 2, -3 is our vertex. So now when we do this table, it's based off of that vertex. It's going from there. So then x, and then what we're actually going to do here, we're just going to do 0, 1, and 2. Because if you notice in this top one, you can just reflect those points over what we call the axis of symmetry. Okay, it's going to be the same distance away from that axis of symmetry. Okay, so the middle one is our f of x, and for this function is the absolute value of x. So then 0, 1, 2, because the absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. Now, remember, a times the absolute value of x for this one, we actually have an a value that's greater than 1, so we got to take 4 times that second column. So in this one, it's saying 4 times 0, or 0, 4 times 1, or 4, 4 times 2, or 8. So 0, 0, we really don't need to do that 0, 1 because that is just our vertex. It's not doing our shift at all. So on the next one, this is saying right 1, up 4 from your vertex. Okay, and then for the next one, right 2, up 8 from your vertex. Okay, and then we could just reflect those points across the axis of symmetry. And there we have our graph. All right, so we opened up because we had that positive a value. Since we had a value that was greater than 1 for our a value, values that are greater than 1 cause our graph to be narrower. So if you get something between 0 and 1, that's going to cause it to go wider. Domain, again, we can go left and right forever. I'm not restricted at all. I can plug in any x value into this function and get something back. So again, x is the element of all the reals. And then our range. Everything was above this imaginary line that I'm going to draw. And the lowest point we got to was that 3, that negative 3. And everything was greater than or equal to that negative 3. One thing you'll notice, it's always based off that vertex, the y-coordinate of that vertex. Same thing for up here. Okay, that vertex and the range have a similar value. They'll have the same value every time. All right, so last one here. Again, find your vertex. In this case, is going to be negative 3 because we have to think opposite of h and what we see for k. So negative 3, negative 1. We got a negative a value, so that's going to cause it to open down. We have a value that's between 0 and 1, so that is going to be wider. Okay, and domain and range we'll figure out once we actually get this graphed. Have our vertex, which is probably the most important part of this. Go to our table, and then again, we're kind of eliminating these x values every time. 0 is always just going to be that vertex, so let's just do 1 and 2, and again, we'll reflect the points come that time. Absolute value of x, 1, 2. Those two columns will never change for this type of function. And then we got negative 1/3 times the absolute value of x. So we're taking that second column again, this column here, times negative 1/3. So 1 times negative 1/3 is negative 1/3. Negative 1/3 times 2 is negative 2/3. Okay. Now, you really don't need to only use 1 and 2. Sometimes when you get fractions like this, there are some values that are going to be easier to use. Like if I was to use 3, absolute value is 3. 3 times negative 1/3 is 1. Okay, and since that denominator is 3, using those multiples of 3, so if I was to say use 6, okay, 1/3 of 6 is negative 2 when I multiply it by that negative 1/3. So those might be some easier ways to do it. Going the 1 and 2 route is not wrong, but sometimes it's going to be harder. Because I know a lot of you guys do not like to use fractions. Okay, so because if you were to use those points, you'd have to go right 1, down 1/3. Right 2, down 2/3. Okay, so that gets a little harder. So if I use that right 3, down 1, I can get good points. Right 6, down 2. Those points are a little bit easier to deal with. Okay, either way is going to work though. And again, just reflecting those points along that axis of symmetry. And again, that axis of symmetry for absolute value functions will just be a vertical line through the vertex. Okay, domain, we can go left and right forever. We can plug any x value in and get something back. So x is the element of all the reals. And then for this one, it's going to be a little bit different. Again, range is y. And it's always going to include that y-coordinate because that vertex is always going to be the highest or lowest point on an absolute value function. But now we're going down. So everything's below that. So it needs to be less than or equal to. Okay. Well, let's look at our homework here. Absolute value. Okay, there you got graphing. Okay, we got one piecewise function in there for you to graph. Find the domain and range. Okay, and then just finding the attributes to a piecewise or an absolute value function. There are these ones in here. Those can wait till the next lesson because that's when I will teach you how to find the equations. But worry about these graphing ones. And then when you're doing them, you know, label your vertex. Tell me which way it opens, and is it going to go wider, narrower, the same in the domain and range. Again, make sure to come to class with questions. Other than that, have a good day.